Hello and welcome to the 16th IGCSE maths tutorial, and today we're going to be getting into some more geometry. So let's start with 4.4 similarity. Basically, similarity, you can have two objects, they must be the same shape. For example, a square and you have another square. Okay, these aren't squares. But they'll do for now. Okay, they're the same shape, so they are similar. Basically similar. Similar just means the same shape. They can be of different sizes. Congruence, however, they have to be exactly the same. Same shape and the same size. For example, something like this. These are similar, but not congruent. That's probably the closest to a congruent triangle as I can get. Okay. Similarity is not hard, really. We're moving into the harder stuff. Third circle theorems. So first, we're going to need to draw a lot of circles. Okay, pretend this is a circle. And we'll mark point O when green. O. Unfortunately, I haven't got a circle drawing tool on this app. So what we're going to do is we're going to draw lines in blue. And I just need to draw a few lines. So, I'll come back when I've done that. Yeah. So yeah, here's my crude diagram of a circle. And basically, we need to label some points. This is going to be point C. This is going to be point A. This is going to be point B. And we're going to have some angles. This is going to be angle A. Okay. I can't really put, I'll have to do them in colors. This is angle green. Got angle green. We have angle red. Actually, we don't have to worry about it. And we've got angle red here. We know that angle red is equal to 2 of angle green. Basically, angle green is half the size of angle red, and this is quite a useful one. Now, we can also say AOB is equal to 2ACB. And it's called the angle subtended at the circle, so the center of a circle is twice the angle subtended at the circumference. And then there's a proof, which I won't go through here. You also need to remember your vertically opposite angles and stuff. I will, I will go and draw the another circle for the next one. Actually, I can still use this circle. So I'll come back when I've done that. Okay, so what I've got here is a drawing of a cyclic quadrilateral. Now, a cyclic quadrilateral is just a quadrilateral. It's just a quadrilateral where all the points are lie on a circle. Okay, and there are some things we know about this. We know that the opposite angles add up to 180. So angle green plus angle blue equals 180. Angle red and angle pink all add up to 180. So red plus pink equals 180. Green plus blue equals 180. Or A equals C and so does B equal D. All equal to equals 180. And finally, I probably don't need to pause the video for this one. It's my... Oops. Okay, so in this situation, the angle at a circle, angle at a semicircle is always added to 180. No matter what angle you draw, let's see if I can fit one more in and read. No matter what angle you draw, it'll always be 90 degrees, a right angle. Even like this, it will still be a right angle. Always will be a right angle. And those are basically the 3 rules of circles. Now, because of my drawing limitations and a small screen, I can't really do an exercise with this. So, we can move on. Now, the next one is constructions. Now, it's a bit hard for me to do constructions, since I don't really have a compass or ruler or protractor. Well, I do have a ruler and protractor, but I don't have compasses. So, I will show you the basic constructions, but I know they'll be quite rough constructions, but I'll try it done anyway. And I'll do the pencil lines in thin. Yep. Okay, first one, perpendicular bisector of a line. Perpendicular bisector of that line. A and B. So what we do is we put our compasses at A and put our compasses at A, and we'll make it slightly more than you make it extends slightly more than halfway, like maybe to point Q here, Q, and draw an arc from there. Now I'll assume my job of drawing an arc at Q. Okay, that'll do. And repeat a similar process with for B, making another point, maybe R or so. Point R. Okay, and you should have 2 lines looking something like this. Okay, and you just put your ruler down, and you connect the two lines there. You connect the 2 dots. Now, as you can see, I have not made a very accurate diagram because my line is not actually perpendicular bisector, and yeah, the arcs are not quite right. But if you do this on paper, you can also Google it. You'll see maybe perhaps a better one because I'm very good at this. Now, next one, bisector of an angle. Angle bisector. This is quite possibly the most useful one. Okay, so basically, what you do is you put your compass at point A, and you what you do is you make an arc like this, like that, and it'll make a point B and a point C. What you want to do is leaving your compasses at the same length. You start at B and just make a small arc around here, and you're keeping them at the same length. And you should just make a small one. You can make a big one if you like. Just making small, and do the same with C. No. Yep. And you should get something that looks like that. And then you just put your ruler at A and put your ruler at D, and just connect these up like that. And these angles should be equal. The final one is a 60-degree angle construction, and all this one requires is 1 point. And it can also be used to construct an equilateral triangle. So what you do is you put So this is point A we have here. This point B we have here. So extend your compasses to the length of AB, and you should be able to draw an arc like this, and another one like this. It should look something like that. Then from point C, actually you don't need to do that. Now you just join up with your ruler points A, B, and C. Just join up points A, B, and C. You have a 60-degree angle here, or if you like, you can continue it to make an equilateral triangle. And the constructions questions are really just easy ways to get marks. It's really easy to get marks in locus questions, constructions questions. They also involve measurement, but that's just popping a ruler down and measuring and using your protractor to measure angles. So that's not hard. Next is, I think this is the last thing we'll do today. Yeah, because then we'll be into the chapter. The last thing is nets. Okay. Basically, I need to draw a cube. Okay. If this cube was made out of paper or cardboard, and you cut the edges and laid it flat, you would have a net of the cube. Basically, basically a thing you fold to make the cube. Now, a net of a cube. Oops. It looks something like this. You should have this. Just gonna. And basically, we only use nets really for geometry questions. Unfortunately, which it was, there is no question in the exam which says make a cube using one of the following nets and with tape and glue. Sorry, there's no question like that. Basically, you just have to be able to recognize some nets. And this is the basic net of a cube. Now, it's not really a cube. It's like a rectangle, but that's the basic net of a cube. And if you were to print this out and fold it up, you wouldn't make a cube. But you can print some online and just play around with those and fold them up and stuff and glue the edges together and have some fun with that. But one thing we might want to do is we might want to see how nets can be applied by doing a question. So this is question number 4. I can actually do this question. No, I can't actually do this question because I can't actually put it up on this board. But try and do it yourself. And if you have any questions, just send it to me. In fact, if you have any questions with any of this book, send it to me. Now, thank you for watching, and we'll see you next time for Algebra 2. If you've got any questions, just leave them in the comment section. But for now, I guess I'll see you next time.